Hello and welcome back to Pre-Algebra with Miss Betsy. Welcome to you today as you join us as we continue our study of solving algebraic equations. We've been working with some word problems. What we're going to do today is see that it's the distributive property that allows us to combine like terms that include variables. For those of you who are following along with me and my text, I am on page 259. I'm in section 8.4 entitled Solving Equations, Simplifying with a Distributive Property. My text is Pre-Algebra for Christian Schools, published by Bob Jones University Press, first edition. Use any text that you like. Now, before we get started, I have ultra lame joke for you today. This is one my kids told me when they were tiny. I don't have any books, so you get to listen to this one today. Knock, knock. Who's there? Banana. Banana who? Banana, banana. Very good. Knock, knock, Mom. Who's there? Banana. Banana who? Banana, banana. Seriously? Knock, knock, Mom. Who's there? Orange. Orange who? Aren't you glad I'm not a banana? So, you'll remember that our distributive property is something that's been very valuable to us. And if we had something that looked like this, 4 times the quantity x plus 2, we knew that that was 4 times x plus 4 times 2 gave us a value, or gave us a simplified form of this expression where we have 4x plus 8 is the same as 4 times the quantity x plus 2. And we use the distributive property because we're trying to add together two terms that cannot be combined. Variables and constant terms are not like terms, so you can't combine them, which is why you have to use the distributive property to end up with the correct result to this multiplication of 4x plus 8. Now, if we had something that said x times the quantity 2 plus 7, we wouldn't typically use the distributive property, would we? No, it's a waste of your time, because contained within these parentheses here, we have 2 plus 7. It's a simple addition problem. 2 plus 7 is 9, so you have 9x. But let's pretend that we were just having one of those days and we didn't think to combine, to do our addition with inside the parentheses first. And we thought, oh, okay, I recognize this. This is distributive property. So I'm going to say x times 2 plus x times 7, which is 2x plus 7x, which is 9x. Okay? Just a slightly different approach to take. Frankly, a waste of your time, but what your text wants to show you here is that you can actually work the distributive property in reverse. So if we were to start out with 2x plus 7x, we could go back and say, oh, I can factor out this x, which is found inside of both of these terms here. What do I have left on the inside? I have a 2 plus 7, which gives me a 9x. So what they've done is they've shown you, and they want you to understand, that it's the distributive property that allows you to combine like terms by simply adding the coefficient. Let's do a little bit of review here. Vocabulary review. Say that we have this, 2x squared. This is an exponential expression. 2 is the exponent, x is the variable, and the large 2 here is called the coefficient. What we're seeing is that when you have variable terms, you have a coefficient and you have a base. And if you have the same base, you have like bases, all you have to do is add the coefficients together and you keep the base. 3 plus 4 is 7x. This is what they want to show you, that by using the principle of the distributive property in reverse, you arrive at a combination at the sum of 3x plus 4x. 3x plus 4x is 7x. And to take it way back into elementary math, where instead of using x's, let's say that we had 3 hearts plus 4 hearts. How many hearts do I have altogether? Well, I have 7 hearts, don't I? Didn't have to worry about, it's not 7 heart. I just got 3 hearts here, 4 hearts here. Altogether, I have 7 hearts. And that's what we're talking about with combining algebraic terms. Now let's say that I had 3 hearts plus 2 stars plus 2 hearts. How would I combine this? How would I describe to someone else what I have here? Well, I would say I have 3 hearts plus 2 hearts would give me 5 hearts plus 2 stars, right? And that makes sense to us because we know you can't combine a star and a heart together, can you? Well, that's all that we're doing in algebra. I'm sorry I don't have a different color marker with me today, but this would be similar to 3x plus 4x is equal to 7x. We have the like terms, the bases are the same, which is an x. We add the exponent, we add the variable. I'll get the right word. See why I say it's important to know your vocabulary? We add our bases, add our coefficients. We add the 3 and the 4. I think what I'll do here, since I was so tongue-tied on this, is remind you that this is the coefficient. I spoke it to you several times. Go ahead and write it for you. What we do is we add the coefficients and we keep the base. 3x plus 4x is 7x. This problem, however, here would be like saying 3x plus 2y plus 2x. What like terms do we have? The x's. 3 plus 2, 5x plus 2y. There's no way you can get that x and y together. They are not like terms. Okay? So let me go ahead and do just a couple of examples, and then we'll be done with this video for section 8.4. Say that we have 3x plus 6x is equal to 117. What do we need to do this? Well, if you have like terms, you combine them. 3x and 6x are like terms because the bases are the same. The bases are the same, we add the coefficients. 3 plus 6 is 9x is equal to 117. X has been multiplied by 9. We perform the inverse operation, which is division. We divide by the same amount that it's been multiplied by to both sides of the equation, and we see that x is equal to 13. Now you can go ahead and do that on division. 2 goes into 11, you have 2 left over, 27. 3 times 9 is 27. Take the time and do your division out longhand. Very straightforward. Makes sense. 3 apples plus 6 apples is 9 apples. Okay, if there are 9 people, well, and right there's where my analogy went, fell apart. 3x plus 6x, 9x. 3 apples plus 6 apples, 9 apples. Okay? Let me go ahead and do another example here. By the way, how would I check this? You would substitute the 13 back into our original equation. 3 times 13 plus 6 times 13. Is that equal to 117? 39 plus 3 sixes are 18, 78. Is that equal to 117? 70 and 30 is 100 plus 17. 117 is equal to 117. So that's how you would check this problem. Let's go ahead and do another example. We also want to check this one. 8x minus 4x is equal to negative 92. And we want to find out what value of x. But we don't care about 8x minus 4x. We want to find 1x. So we have to combine these x's together. This time we're subtracting. The bases are the same. The terms are the same. They're like terms. The exponents are also the same. We're simply going to subtract the coefficients. 8 minus 4 is 4. X is equal to a negative 92. We now have 4 times x is equal to 92. The inverse operation for multiplication is division. We will divide both sides of the equation by 4, and we end up with x is equal to 23, and it's negative. A negative number divided by a positive number is negative. Our problem also tells us, go ahead and check this, make sure that you got the right solution. Makes sense. 8 times a negative 23 minus 4 times a negative 23. Oh my word. Have to do the arithmetic. Is that equal to a negative 92? What's 8 times 23? 23 times 8, 3 8s are 24, carry 2. 184, but it's negative. 184 minus, what is 4 times the negative 23? 4 times 23 is 1292. Minus a negative. Having a hard time with my writing tonight. Minus a negative 92. Is that equal to a negative 92? Now some of you are looking at this right here and saying, what did we do wrong? I know if I subtract a negative, that's addition. This is not true. Look at this and see if you can catch what part of this problem I left off. 8 times 23 is what I multiplied here on purpose. What do I really have? I have 8 times a negative 23. The product, because I have a positive times a negative, is a negative 184. This is a good illustration to why you have to constantly be on your guard. Make certain that you're not dropping a negative sign. Now we have negative 184 plus 92. Is that equal to a negative 92? And yes, it is. When you're adding oppositely signed numbers, you subtract the big number from the smaller number from the apparent bigger number, and you keep that sign. 184 minus 92 is 92. We keep the sign that goes along with the negative 184. Negative 92 is equal to negative 92. And that's the conclusion of our lecture on section 8.4. I'll see you next time.